Hi, today I want to play around with the ESP32 MQTT, the Mosquito server, openHAB, and an Android application named MQTT Dash. So this episode is a little bit full, so I cannot explain everything in detail, but it's just an overview so we can do a follow-up with all the different kind of software installation. And beside the ESP32 part, Mosquito and also openHAB can either installed on the Raspberry Pi or on a Linux-based system, or maybe on other OS as well, but I don't try it. Let's start by a sample setup. On the one side, you can use one or many ESP32s and connect them via Wi-Fi to your access point or router. And on the other side, you can use a Raspberry Pi or a Linux system or what have you and connect it all together in your local network. Before we continue, I explain the ESP32 MQTT message I use. The ESP32 subscribed to a message ESP32/bulb1/#, and that's the first part is for the device, so I can use for every ESP32 another device identifier, and the last one is for the GPIO port. I use an array to identify the GPIO port, so it starts just continues by 0, 1, 2, 3 and so on. And then the message is only the duty cycle for the GPIO port. And then I can publish some messages. They all start by ESP32 bulb1, and this message is for GPIO port identified by 0, and I switch it off because the duty cycle is 0. So this is for GPIO port 5 and it's switched off. And the next topic is the same, but we use a different message. We use 100. So the GPIO port 5 is switched fully on. And then the next topic goes to the GPIO port identified by 1, and it's only half on and half off. So this is for GPIO port 18 with a 50% duty cycle, and so on. So let us start by installing and configuring the Mosquito server, and I just rush over a few steps. So I configure the SSL, TLS certificates and keys, configure the Mosquito configuration for using users and passwords and so on, and then I restart Mosquito. And here's my Raspberry Pi startup, but unfortunately I cannot really catch the screen from the Raspberry Pi with my hardware, so I switch to Ubuntu to show you the example. These are my steps to install the Mosquito server, but you can use maybe also an internet-based Mosquito server. But this is the steps. I installed the software on Raspberry, and also I tried it on Ubuntu, and I tried it also on the newest Ubuntu 17.04, but on this system I show you this is my old Ubuntu 16.04, long time. So after installing, we can test our Mosquito server, and I've done it already. And then I secure my Mosquito servers with an own certificate and an own server key. And then I copy all the keys to the Mosquito configuration, and that's the same on Raspberry and Ubuntu. And we also secure our unencrypted port, so that no one can reach the unencrypted port from outside our own server. So this is only for local testing only. And then I also introduce an user and password so that no one can use the Mosquito server anymore without a user and also without a password. And this is only an example, so the user don't have to be sensor1, and the password certainly also use a different one. So after that we can test our Mosquito servers running. So we subscribe to everything that is going to the ESP32, and we also use our local port and our user and also our password. So now we get some messages, but let's produce our own unencrypted messages. So we open the second terminal and just a hello message to our subscribe client on the same server. And now we receive our message. But that's not very interesting. Interesting is, can we use also something with encryption? I also use the second port without WebSockets and also a certificate to switch on the SSL encryption with our connection. And also we use the user and the password. And this message goes directly to the ESP32, but we discuss this later. So we got our message 100, and we can also send maybe the message 10 or 0 or what have you, or also test or what. Now let's test also our ESP32 firmware, and I connect to the ESP32 by typing in make monitor. Then we can see the output of our ESP32. We connecting to our Wi-Fi like this, to a hotspot called ESP zone. Then we connect to our Mosquito server and we're waiting for the next message. And now we can test this. Here we send test to the ESP32, and the ESP32 expect a message on this topic. That is have to be ESP32 bulb 1, and the subtopic also steers the GPIO output. So 0 is for the first configured GPIO, 1 for the second, and so on. And the message steers the GPIO level for the LED library. So we can set different levels between 0 and 100%. So if I just type test, then the ESP32 don't understand the test. And it's understand the rest of the message. So we can maybe send something different, maybe like bulb 0, but then the ESP32 don't respond. So it's have to be bulb 1 in this case. And if we send 100, then the LED on GPIO pin for the first configured GPIO pin switches fully on. So let's do it. And certainly we can also use different levels like 20% or maybe 10% and so on. So now we know our ESP32 is connected to the Mosquito server and all the different messages received by the ESP32, and we can go a little bit further. And now continue with the openHAB installation and configuration. I found out that openHAB2 is not able to run on Oracle Java 9, so I have to disinstall the Java 9 engine, and you find out what Java version you are using just by typing in Java -version. And I'm using Java 9, but now I have to deinstall it, so I remove the Java installer and install again Java 8 and set Java 8 to the default Java environment. And now if I type in Java -version, then I get the 1.8, or also called the Java 8 version. Then I downloaded the openHAB packages and install it all manual, so I don't use this automatic package on my systems. Then I start up openHAB and install it also as an full automated service, so I don't have to start it every time if my systems reboot or similar. Then I installed the MQTT bindings and configure the MQTT entry, and I use my local Mosquito server and also the encrypted version with password. And for this purpose I use quality service 1, but maybe I have to switch it to 2, so I have to do further research on this topic. And then I introduce some items so we can connect some openHAB items to MQTT messages. And again, analoglamp.com sponsors 1 giveaway today, not 2, just only 1. And I also don't know what you get. It's either a ESP32 development board or an ESP32 module. And please read the terms and condition in the description down below and here on the video screen. And now we start up openHAB in our browser, and certainly I have to encrypt it, but I do have to do further research how I can encrypt the connection to the openHAB server. So let's start by open the paper user interface, and I just do a configuration and I show you how to add the MQTT binding add-ons. So we search for M and MQTT, and as you see, I have already installed the MQTT bindings. So you just press the install and that's it. So we can go back to our start page of openHAB, and now the rest is just in the HAB panel. And I've already played around with a dashboard. So this is my dashboard and we can see the items that I've configured. So let's start by this item. We give it a name and also an item name. And I write a small text file for the configuration to do this, and this goes to the configuration directory from openHAB to the items path, and we can name it whatever we like. I think the only thing it have to be .items at the end. So I start by introducing bulb1, and then we can see the different message that I'm playing with. So first I defined a switch, and the switch has also a MQTT connection to our Mosquito server and sends the MQTT message to our ESP32 with the bulb1, and this is for the first configured GPIO port, and we just send the command on, and then we send the number 100, and if we send off, then we send the number or the message 0. And the same is for incoming message. If we get in 100, then we switch to the state on, and if we get 0, we switch to the state off. So after we configure this, then we can use this openHAB item, and we can set maybe a little icon and hide the name and what have you. So let's run it, and we can switch on and off, and I also show you the MQTT window. So this is our MQTT output, and we see if we press the button we get the off state, but I don't know why we get 2 messages, so I have to do further research on this topic. And if we press again, then we get the 100 message. And also I have defined a number, and we can also switch between different states, and I also get here some strange behavior. So if I put here default, then my openHAB server does an endless loop and just switch between every state you're connecting. So I have to do further research on this topic, but as we see, we can press here and here and here, and the range we press on the slider, then we get the corresponding message to our server. And also the ESP32 gets this message and respond by dimming the LED. So, and same for the second LED. This time I defined bulb11, and we toggle between two commands toggle between on and off. And also we toggle the colors, and we have also an icon here. So if we run this, we toggle also the background color, and also our LED goes on and off. So let's open also the configuration file on bulb 2, and as you see, we have also defined a switch for bulb 11, and if we press it, we also get the 0 and 100 message. And the same for the slider. I also use this number dimmed, so we can see also these messages. And now the demonstration with MQTT Dash on my Android phone and the ESP32 connected to some LEDs with 220 ohm resistors to the GPIO ports of the ESP32. And here's the ESP32 setup on the bench with 4 LEDs, and I use my mobile phone with the MQTT Dash application. And as you see in the background, if I press this configured button, then the green LED goes on and off. And certainly we also can dim the LED with the slider. So let's see what is if we do 50% duty cycle, or let's play with the second LED, the red one. We can switch it on and off. And now toggle between the LEDs, or let's dim also the red LED, the third one, or let's bring it to 100% duty cycle, so full on. So let's play with the second one again. And after we played enough with the LEDs, then we can have a look into the button definition inside MQTT Dash. And we see there's a name we can use, and the MQTT topic we programmed into the ESP32. And also we use publishing, so we also send out the MQTT state message, and then we can set the different values and some icons and the colors and quality of service and so on. And if you like, you also can play with some JavaScript programming with the MQTT Dash, but I don't use it. And now a look into the source code. I start by the main task, the subscribe main task for the MQTT messages. And I use the PAO client, PAOC client from Eclipse. And I've written my own wrapper for the embed TLS connection. So everything is encrypted. And now I'm using mostly the connection with web sockets, because this is more stable than the other, and I have to do more research why this is so. But for now, just explain how this works. And I've defined my own Mosquito server and the Mosquito user and the Mosquito password and the Mosquito port. And here is defined that I use the WebSocket wrapper for the connection, and here's the array for my GPIO ports. So this is 0 is GPIO port 5, 1 is 18, 2 is 23, and so on. And this is for the debug messages or logging messages, so I use everything with the MQTT S for secure. So this is the standard connection to our Wi-Fi event handler, and initialize the Wi-Fi, and here is the password and also the Wi-Fi SSID and so on. So let's now start by the main task. I initialize the Wi-Fi connection, then I create the MQTT task, and we can have a look into the MQTT task. The MQTT task waits for the established Wi-Fi connection, then starts a MQTT client, initialize the network for the MQTT, then initialize the MQTT client and configure the MQTT client with the username, the password with the correct MQTT version and client ID and so on. And I use a random client ID for the production and for debug just a fixed client ID. So it's easier to debug the MQTT messages, but that's not so relevant for today. And then we connect to the MQTT server, subscribe with our message as explained earlier, and then we just yielding for new messages. And all the message that are received goes to the MQTT message handler, so we can have a look to the message handler. And the message handler just parses the received topic and also the received message. So we just extract a GPIO number and a duty number, convert this to a real integer, or in this case an 8-bit integer with no sign. And then we use this function to set the LED on the configured GPIO pin, and I use the GPIO number to set the LED library. So let's have a look into this function, and the LED channel is used just by the GPIO number. So, but the number of channels you can use from the LED library is limited to maybe, I think, 8 channels. So it starts by 0 and goes up to 7. And you cannot use then more than 8 GPIO ports with the LED library. So you cannot set more than 8 channels using the so-called digital to analog converter. So, and that's it for today. So I hope you find this video interesting, useful, and you learned something. And if so, please give me a thumbs up or subscribe to my channel. I wish you a nice day and bye bye.